How's it going, everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys everything you need to know to get started with Java, so sit back, relax, and enjoy the show. If you wouldn't mind, please like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Here's an outline of the topics covered in this video. If you would like to skip ahead to a certain section, feel free to click on any of the timestamps posted in the description. Also, at the end of this video, we're going to be discussing some tips and tricks, so be sure to watch until the very end. I'll give you 3 reasons why you need to learn Java. Besides being one of the top 3 most popular programming languages worldwide, Java is an extremely flexible language. It's used extensively by business enterprises, Android apps, games, and if you learn Java, you could land a job as a Java developer. According to Glassdoor, entry-level Java developers have an average starting salary of $70,000. That's nothing to sneeze at, so why not learn Java? Are you still here? Okay, cool. Let's begin with the basics. Computer languages are on a spectrum between being high-level and low-level. Computers only understand binary. It's referred to as machine code. It's a low-level format that a machine can understand. However, humans have difficulty reading binary since it's all ones and zeros. To create machine code, we write in a format called source code, which is understandable by humans, and compile to machine code. When we create Java source code, the file ends with a .java file extension. Think of compiling code as transforming source code to machine code. We do this because machines can't read source code and vice versa. Humans have trouble reading machine code unless you're a robot or an android or something. However, when we compile our source code to machine code, it's machine-specific. If we write source code and compile on a Mac, we can only run that code on a Mac, and the same concept applies for PCs. Although, the Java language has a solution for this problem. With Java, we have an intermediary step where we can compile our source code to a format called bytecode. Bytecode is cross-platform and ends with a .class file extension. Here's an example of Java source code, and here's an example of that same source code after we compile it to bytecode. It's kind of funky, right? Since bytecode is cross-platform, you could write your code on a Mac and then send your bytecode file to your friend who can then run it on their PC using a JVM to translate the bytecode to machine code. But we are going to need the help of a JVM to translate bytecode to machine code. But where can we get a JVM? Well, it's included with a JDK. And what is a JDK? Well, JDK is an acronym for Java Development Kit. It contains developers' tools to help us code, as well as a JRE, a Java Runtime Environment, which contains a library, toolkits, and our JVM, which is another acronym for Java Virtual Machine, which translates bytecode for us to machine code. So all you need to worry about is downloading a JDK, and everything else will be included. And now that we know what a JDK is, it's time to download one. So open up the internet and go to any search engine and look this up. Java JDK download, go to the first link, Java SE downloads. SE stands for Standard Edition. Go to JDK download, scroll down and find the appropriate file for your operating system. Since I'm running Windows, I'm going to download this EXE version. Agree to whatever, and download. And when this finishes downloading, I'm going to open this. Open when done. On my computer, I currently have a JDK already installed, but I'm going to go ahead and reinstall it for the sake of this video. Click Next, Next, then wait a little bit, and close. I would also recommend an IDE. That's another acronym, and it stands for Integrated Development Environment. Think of it as software that helps us write other software. You could write code with a text editor such as Notepad and then compile the text file, but doing so is not really beginner-friendly. So an IDE provides an interface for us to write code, check for errors, compile, and run code. There's 2 IDEs that I would recommend. They are both Eclipse or IntelliJ IDEA. It doesn't matter which one you download because the code that we write is still the same. So let's download an IDE. Now it's time to install the IDE. I would recommend either the Eclipse IDE or IntelliJ IDEA. I'm more comfortable with Eclipse, so I'm going to stick with Eclipse. So go back to the interwebs and look up either Eclipse IDE or IntelliJ IDEA IDE. So I'm going to look up Eclipse, click the first link, click this orange download button, go to download packages, and select Eclipse IDE for Java developers, and select the correct download for your machine. I'm going to select the download for Windows, and click download. And then just wait a little bit again, like usual. For me, this is currently a zip file, so I need to select this file and extract all. With the newly extracted folder, navigate to this Eclipse application. So you can select this to launch Eclipse. For convenience, I'm going to create a desktop shortcut. So for me, I'm going to go to, where is it? Send to, create desktop shortcut, and then click to launch. You can select a workspace. I'm going to use the default and click launch. We are now within Eclipse and we can begin a new project. We are now ready to rock and roll. So let's begin by creating our first Java program. But in order to do so, we need to create a Java project. If you're brought to this welcome screen, you can close out of this because it's annoying. And in order to create a Java project, navigate to your Package Explorer and select Create a Java Project. If you're missing the Package Explorer, you can go to File, New, Java Project, and that will take you to the same place. We need a unique name for this Java project. I will call this My First Program. And I will want to configure the JRE, the Java Runtime Environment, and we downloaded that with the JDK, because the JRE is a component of the JDK. So I'm currently using 13. I'm going to change this to 15. That was the one that I more recently downloaded just now. So go to Configure JREs, and I'm going to click Add. Select Standard VM. VM is Virtual Machine. Click Next. Go to JRE Home. Go to Directory. And I'm going to make sure that I'm selecting the most recent JDK. For me, that is 15. Select Folder, Finish, Apply, Apply and Close, then Finish. If this window pops up, you can select Don't Create. That's to create a module. If you look to the left-hand side within the projects folder, we now have a Java project called My First Program, but we will need to add what is called a class to this project. A class is a collection of related code. So in order to add a class to this project, I'm going to select this project folder, then go to File, New, Class, and we need a unique name for this class. I usually call this main, but you can name it whatever you want. And then we are going to check this public static void main checkbox, and then click Finish. With that out of the way, take a look back within your project folder, and you should now have a Java file that shares the same name as your class name. My class name is named main, therefore my Java file is also called main. So this has the .java file extension, and with what we discussed before, this is source code. It's in a format that humans can easily read and understand. And when we compile this source code to bytecode, we're going to create a new file that has the .class file extension. And with that bytecode file, we can run that and translate it using a JVM, a Java Virtual Machine. Here's our Java file, and we have our class, and mine is called main. So all the class is that it's a collection of related code. We won't be exploring in depth on the topic of classes until we reach the subject of object-oriented programming, which is about 20 videos into this playlist, so you have some time. So this is our class. Mine is called main. Anything within the outer set of curly braces belongs to the class and is contained within. And within our class, we have what is called a main method. Our program won't run without this method because when we run our code, we begin by calling the main method. So if we were to compile and run this code, you can do so by clicking the screenplay button. All output is displayed to the console window, and nothing appears to happen because we haven't written anything yet. So if we were to remove this main method and tried to do this again, we would encounter an error because our main method was not found in the class main. It's asking us to please define the main method. Now, looking back, when we created our class, we went to File, New, Class, and in order to generate the main method, we checked this checkbox here that states public static void main. So the main method generated for us when we created this class, but if we're missing it, we can easily just type it in. A textbook that I read in college said to think of the main method as a magical spell or incantation that we have to say in order to get this program to run. So we are currently missing a main method, but we can easily just type it in. So repeat after me. Public static void main, then we need some parentheses, string, straight braces, args, and then a set of curly braces, and that is it. We now have a main method. And our program runs and compiles just fine. So any code within the main method will execute starting at the top and then work its way down. So with the main method, any code you place at the top will be executed first. So let's print something to the console window. In order to display some text, all you have to do is type this. System with a capital S dot out dot print. Then you need a set of parentheses and then a semicolon at the end. So within the parentheses of this print method, we can type some text to display to the console window, but we need to make sure that our text is within a set of double quotes, and we can display some text. Let's say, I don't know, what's a food you like? I love pizza. So if I were to run and compile this, it's now going to print I love pizza to the console window. Let's say that we would like to display another line of text directly underneath the first. We can accomplish that by using another print statement. So for convenience, I'm going to copy this first line, paste it directly underneath, and display some other text, such as, it's really good. So when I compile and run this, pay attention. The output is one long line of text. The reason that this is all displaying as one long line of text is because after printing the first statement, our cursor does not move down to the next line. In order to do so, we could use a println statement, short for print line. It's as if we're hitting enter when we finish outputting our text. So let's try this again using a println statement. And now each line of text is on its own individual line. So that's what distinguishes a print and print line statement. A print line will add a new line character as if you're hitting enter when you finish outputting your text, whereas a print statement does not. So that's the difference between the two. An alternative to using a print line statement is that we could stick with the standard print statement and at the end of our text add what is referred to as an escape sequence for a new character. Now, an escape sequence is a character preceded with a backslash, and one of a few characters that follows directly afterwards. This is an escape sequence for a new line character. When we add this escape sequence for a new line, it's as if we're hitting enter wherever we place this escape sequence. So within our string of text for our first line, at the end, we're going to add \n, and this will have the same effect as a print line statement. It's going to display our text and then move the cursor down to the next line. As you can see, there is no additional change to the output within the console window. Now, what if we reverted our print statements back to print line statements and kept the additional escape sequence in for a new line character? Well, we're going to have an extra empty line of text because we're displaying our line of output plus an additional character for a new line, and then we're hitting enter at the end via the print line statement. So we're going to have an additional empty line between these two lines of text if we were to do that. So a few other escape sequences that you might be interested in include the following. A \t will add a tab. So let's precede our text with an escape sequence for a tab, which is \t. So this is if we're hitting tab before displaying our text. And we now have some empty space preceding our line of output. If you need to put something within quotes, let's try to do so normally. So our compiler is actually going to be confused because we cannot normally add a set of quotes because our text already needs to be surrounded with quotes. So if we need to literally display some quotes, some double quotes, we need to precede our double quotes with an escape sequence. So \, then quotes. So this will allow us to literally print some double quotes. So we're going to surround our first line of text with some double quotes now. And if you need to display a backslash, then you need to use double backslashes. Because if you use just one, your compiler thinks you're trying to use an escape sequence. And that's how to display a backslash. In summary, anything preceding with a backslash is the beginning of an escape sequence, and there's one of a multitude of characters that could follow afterwards. And depending on the character, this has special meaning for your compiler to do something specific. Now, anything that is following 2 forward slashes is the beginning of a single line comment. I could write, "This is a comment," and this line of text is going to be ignored by the compiler, so there's going to be no change to this program with the additional comment. Anything that is a comment is ignored by the compiler, so it's useful if you need to leave yourself a note or for somebody else that's looking over your code. If you need a multi-line comment, that is a forward slash followed by an asterisk. And anything up to an asterisk and another forward slash will be the bounds of this comment. So I could write, on a new line for each word, "This is a comment," and all of this will also be ignored by the compiler. So that's how to write a multi-line comment, a forward slash and an asterisk, and anything up to another asterisk and forward slash. So those are comments. All right, ladies and gentlemen, it's time for this section on tips and tricks. And for my first trick, I'm going to change the color scheme of my IDE. We're currently using the light theme, but I much prefer the dark theme. I'm going to be joining the dark side. So in order to change the color scheme of your IDE, go to, if you're using Eclipse, Window, Preferences, under the General tab, go to Appearance, Theme, and you can change the theme here. I will click Dark. I'm going to select Apply. Okay, and then Apply and Close. So the dark theme is great if you want to feel like a pretend elite hacker. For my next trick, I'm going to change the font color as well as the background color of my console window. In order to do so, head back to Window, Preferences, under Run Debug, go to Console, and you can change the color schemes here. I'm going to change the text color to a bright green, click OK, as well as the background color to a slightly lighter shade of black. That should be good. When you're finished, click Apply, and then Apply and Close, and you may need to run this again to see the changes. So that's how to change the font color as well as the background color of your console window. So it's somewhat tedious to have to write a println statement, correct? System.out.println. Normally that's a lot to type, so a shortcut would be to type sysout, then hold Control Space, and your IDE will auto-generate the rest of this println statement for you. Let's move on to trick number 4. Let's say that we have hundreds of different println statements and we need to change the text to print because we made a mistake. So there's a feature where we can replace some text in your program with another. So let's pretend we would like to replace println with print. So go to Edit, find Replace, and we can replace some text with something else. Let's find each instance of println and replace this with print. Then click Replace All. So that will take care of all that for you. Let's move on to some final tips. So with spaces, spaces don't make much of a difference within your code. For example, after this dot and my print portion of this print statement, I could add a bunch of spaces for no reason, and this would run and compile just fine. I'm not sure why you would do that, but that's just to reinforce the point that spaces don't make much of a difference. Unless you're using a space to split up some keywords, then you might run into an issue, or if you're adding space to a string, well then that's going to have a noticeable effect. So spaces, for the most part, don't really matter too much, depending on where they are. Here's a trick on zooming in or out. Hold Control- to zoom out, or Control+ to zoom in. Or you could go to Window, Editor, then zoom in or zoom out within this menu. Here's my last tip for you. Let's say you accidentally close out of your Package Explorer or your console window. You can easily bring those back by going to Window, Show View, and then they are all listed here. So I would like to bring back my Package Explorer as well as my console window. Alright guys and gals, you should be ready to get started with Java. Be sure to check out the full 100 video playlist as well. And if you could do me a small, tiny favor, I would greatly appreciate it if you could help me defeat the YouTube algorithm by smashing the like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey you. Yeah, I'm talking to you. If you learn something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys all about variables in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys and gals, let's talk about variables. Now a variable is a placeholder for a value, and it behaves as the value that it contains. Do you remember from either elementary school or middle school when we were working with algebra, we usually had to solve for some sort of variable like x or y, and x or y contained some sort of numeric value, and for all intents and purposes, this variable behaved exactly as this value. Well, with programming, we can perform something similar to that, but we're not limited to just numbers. We could also store words, whole sentences, and these things called Boolean values, which hold either true or false. But if we're going to store a value within a variable, we have to list the data type of what we're planning to store within that variable. Is it going to be a number, a word, a Boolean? So we need to discuss data types. There are 8 primitive data types and a special reference data type called a string. Anything that I have noted with a star is particularly important, so I would pay special attention to these. Our first data type is Boolean. This has a size of 1 bit, so it can only hold 2 values, that being true or false. If we're attempting to assign a Boolean value, we would type either equals true or equals false. Something similar would be, let's say we have a light switch program. Well, if the light switch is on, we could say that the light switch has a value of true. If it's off, it has a value of false. So this is binary. That's why it only uses 1 bit. It only needs 1 bit of memory to function. Next, we have byte. This isn't as important as a few others, but with 1 byte, we can hold an integer number between -128 to 127 because a byte only has 1 byte of memory. A short has 2 bytes of memory, so it can hold a larger number between -32,000 and some change to 32,000 and some change. So integers are important. These use 4 bytes of memory, and they can store a number to just under 2 billion to just over 2 billion because they use 4 bytes of memory. And a long, they use 8 bytes of memory, so they can hold a very large number. In fact, they can hold a number between just under -9 quintillion to just over +9 quintillion. Now a float, they can store a fractional number, specifically up to 6 to 7 digits. What makes floats different from these data types on the top here is that bytes, shorts, integers, and longs can only store a whole integer. They cannot store this decimal portion. So if you're working with a program or a variable that uses a fractional number, you'll need to use either a float or a double. And a double has more precision. It uses 8 bytes of memory, and it can store a fractional number up to 15 digits. So in comparison with a float, this has less precision than a double. And for an example, I just listed a few of the digits of pi. With this example, we can only store 6 to 7 digits of pi, but with a double, we can store up to 15. There is one strange convention with floats. If you're going to assign a value to a variable that's of the float data type, you need to follow the value with the letter F. With double variables, you actually do not need to do so. So that's one major difference when assigning values between these two. Now let's move on to characters, pronounced char for short. Think of Charizard. This uses 2 bytes of memory, and this will store a single character letter or ASCII value. An example would be the letter F, but a common convention with assigning values to a char variable is that you need to surround this value with a pair of single quotes. And our last data type is the string data type. The size really varies because these are reference data types. They store a sequence of characters, like a word or a sentence. You could store a single character within a string, but chars and strings behave differently because chars are primitive data types and strings are reference data types. So let's distinguish the difference between primitive and reference data types. Here's a super quick description between the differences of primitive and reference data types. Primitive data types, there are 8, and we just discussed them. They are Boolean, byte, short, integer, or longs, all those cool things that we just discussed. Reference data types, like strings, well, there's an unlimited amount because they are user-defined. Primitives store data. Reference data types store an address. Primitives can only hold one value. Reference data types could hold more than one value. Primitives use less memory compared to reference data types, which use more memory. And primitive data types are faster compared to reference data types, which are slower. Now you're probably thinking, cool story, bro, but how do we create a variable? Well, I'm glad you asked that question. So the first process with creating a variable is that we need to declare the data type of what value that this variable is going to store. So come up with a variable name like x, and we will precede this variable with the data type of the value that we're planning to store within this variable. And then with all statements, we follow this with a semicolon at the end. The next step is called assignment. We will take our variable and assign it equal to some sort of value of the data type that we declared this variable to be. But you could combine steps 1 and 2 together, and this process is called initialization. We would take the data type followed by the variable name and set it equal to some value, and then add a semicolon at the end to finish the statement. So you can either do this in 2 steps with declaration and assignment, or combine them both together, which is initialization. How about we create a few variables? Does that sound good to you guys? So let's begin with creating an integer variable. Let's say int x. This step is called declaration. We are declaring the data type of what value is going to be contained within this variable. The second step is called assignment. We can assign our variable a value. Let's say x equals 123, and this step is called assignment. Or we could combine both of these steps together, and this process is called initialization. Int x equals 123, and this would be initialization. So we can do stuff with this variable. It will behave as the value that it contains. We could print this to the console window, so within a print or print line statement, we could print the value of x. So make sure you do not write this within quotes. Right now, this will display the value that is contained within x, which is 123, because this variable behaves as the value that it contains. If you were to surround this with quotes, what we are doing now is printing a string literal. You can also print text as well as a variable together. Let's say we have a sentence, a string literal that states, my number is, and then if we want to do some string concatenation with a variable, we would add plus and then the variable name. Make sure this is not within quotes. So this will display the sentence, my number is, plus our variable. And in the console window, it states, my number is 123. So with integer variables, the largest number that you can store within an integer variable is just over 2 billion. Let's say we are working with an extremely large number, like the amount of student debt that I owe. Well, this number is too large to store within an integer variable. We would probably want to use the long data type. And one convention with assigning values to a long variable is that you need to follow this number with a capital L for some reason. So we can now work with extremely large numbers. So this might be useful if you're working with numbers like the speed of light or something. So we now have a long variable and we can display this value. A few of the other data types that we mentioned were bytes and shorts. They have a lesser number that they can store. So with bytes, you can only store up to, I believe, 127. So we could store like 100 within here, and this would be fine, but 130 would be a little too much though. So we don't tend to use bytes and shorts too much as a beginner because it's just way more convenient to work with integers. But you might use longs every once in a while too. But as beginners, we're mostly going to be sticking with integers. Now, a double can store a number with a fractional portion. With integers, we cannot store a decimal portion. So if this was 123.01, well, we cannot store this decimal portion. We can only do so with a float or a double. So with a float, you would type in float for the data type. Let's create a new variable like y. Float y equals 3.14. And a common convention for assigning numbers, well, values to float variables is that you have to follow this with f. So you can store a number with a decimal portion within a float or a double, and then we could display whatever this value is. So y is equal to 3.14, but people tend to use doubles more because they have more precision, and then you do not need this f at the end. So this will store up to 15 digits after the decimal portion. So we also have booleans. Let's say boolean z equals, this holds either true or false. And then we can display what value is within this boolean. So if we print our variable z, this will display false. Or we could hold true, and this will display true, but we can't display anything else besides those two. Like we cannot hold the word pizza because booleans only hold true or false. We have characters, char for short, char, and we don't necessarily need to come up with a variable that's only one letter. We could have a name or something that's descriptive for this. Let's say we have a variable called symbol. Char symbol equals, and then place a character within single quotes. Let's say we want the @ sign. So we now have a variable called symbol that contains the @ sign. So if I were to display this variable symbol to the console window, it will display the value that is contained within, which is the @ sign. And lastly, we have strings. So with strings, these start with a capital S because they are of the reference data type. Anything that's a reference data type begins with a capital letter. And let's say we want to store our name. So string is the data type. Let's say the variable name is name equals, and to store a string, it works similar to a string literal. We're going to use a set of double quotes and display or add a bunch of text like my name. And then I can now display my name to the console window, or I could do some string concatenation too and display the word hello plus my name. And within the console window, it's now going to display hello, bro. So that is everything you need to know to get started with variables in Java. If you would like a copy of all this code, I will post all of this in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. How's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can swap two variables using Java. Let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. All right, well, here we got two variables. We got variable X, which contains water, and variable Y, which I'm gonna put Kool-Aid in. More specifically, black cherry Kool-Aid. So let's just put this in. Good enough. And let's mix it. Perfect. So we're going to create two variables, and these are going to be of the string data type. So we'll have string X equals the word water, and string Y equals the word Kool-Aid. And then let's display these with a simple print line statement. And within here, I'll just type in X colon space plus the variable X. And then let's do the same thing for Y. So we'll change X to Y, and let's display these. So X currently has water, and Y currently has Kool-Aid. So what happens if we set X to equal Y? Well, we get Kool-Aid for both X and Y. Okay, we're gonna assign variable Y to variable X. Shit. So yeah, it looks like we have Kool-Aid in both variable x and variable y. Let's try again. Maybe we can set y to equal x. No, we just got water everywhere. Let's try this again. We're going to assign variable x to variable y this time. Okay, that doesn't seem to work. Guys, my floor is getting really sticky. So it appears that we're going to have to store one of these values within another variable in order to switch these. So one thing that we can do is introduce another variable, and let's call this temp, and temp is empty. Let's create another string. So we'll create string temp, and we can either set this to null, or we can assign no value at all, where we simply just declare temp a variable. So what we're going to do is actually take x and store x, whatever value is in here, within temp. So we are going to type temp equals x. So now x can be filled with something, so we're going to fill it with variable y. So on our next line, we're going to set x to equal y. Then we're going to take our temp variable and store this within y. And lastly, y equals temp. Breaking news, ladies and gentlemen, we have switched the contents of x and y with the help of our variable temp. Now back to you, bro. Thank you for the live update, Anchor Bro. It appears on our end that we have also switched the contents of x and y as well. So in conclusion, if the programming language you're using doesn't have any direct function to switch two variables, you could do this manually, and you can create another variable such as temp. And temp is a temporary value to temporarily store one of these values. You can set temp to equal x, or you can do this with y, and then set x to equal y, and then y to equal temp. So your assignment for today is to post two variables in the comments down below and the code that you used to swap them. And that, ladies and gentlemen, is how you can swap two variables. Hey, how's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys how we can accept some user input in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Welcome back, ladies and gentlemen. I'm going to explain how we can use a scanner to accept some user input. The scanner class is found in the Java utility package of your library, and we need to import that before we can use the scanner. So outside of the class, at the top of our program, this is what we're going to type. Import java.util, and the name of the class we would like to import, which is scanner. Then a semicolon. Now we can use the scanner class to create a scanner object. So we're going to be performing a little bit of object-oriented programming. We'll be covering object-oriented programming in a later part of the series, so don't worry. So repeat after me. Scanner, then we need a name for the scanner. Let's call it scanner, all lowercase, equals new scanner. Then a set of parentheses and a semicolon. Within the parentheses, we're going to type system.in. And there we go. We have our scanner. So we can use the scanner to accept some user input. So let's let the user know that we would like them to type in something, maybe a name. Let's create a prompt that will ask somebody for their name. So within a print line statement, we'll type, "What is your name?" And next what we'll do is take our user input and assign it to a variable, perhaps a string variable called name. String name equals, and now we're going to use our scanner. So we type in the name of the scanner, dot, and to enter a line of text, we're going to use a certain method of the scanner. It is the next line method. And when we type in user input, we type it into the console window here at the bottom. So let's do something with this name, maybe display this within a message. System.out.println, hello, plus whatever your name is. So let's compile and run this. What is your name? Now our program is currently paused until we type in some user input and then press the enter key. When you press enter, that's how you submit some user input into the console window. So I'm going to click within my console window and type in something. I'm going to type in bro, and to submit some user input, you press the enter key. And it states hello plus my name, which is what I entered, bro. Now there's different types of input that we can accept. This time, let's accept only an integer number. Perhaps we can ask somebody for their age. So let's write a prompt for that. System.out.println. How old are you? And this time we will declare an integer variable, maybe called age. Int age equals scanner dot next, and we are looking for int. So we can only accept a whole integer. You are plus age plus years old. Okay, let's try this again. What is your name? Bro, how old are you? Let's just say that I'm 18. Hit enter. Hello, bro. You are 18 years old. So what happens if we do not enter in a number? So let's try and break this. What is your name? Bro, how old are you? We're not going to enter a number this time. Let's type in the word pizza and see what happens. Well, we encountered an exception. We encountered an input mismatch exception because when our scanner is looking for an integer, we typed in a string. So we need to make sure that the input type, the data type, matches. In a future lesson, we'll be covering exception handling, where we can prevent this very thing from happening. But for now, since we're beginners, we'll just have to be sure to type in the correct data type of the input that our program is looking for. Now, there's one more thing that I want to show you guys. This is a common problem if you use next line after next int or anything else that's not next line. So let's ask somebody for their favorite food this time. So let's add that at the end. System.out.println. What is your favorite food? Then we'll create a string variable called food. String food equals scanner dot next line. And we will display this. System.out.println. You like plus food. All right, so here are the questions. What is your name? Bro, how old are you? 18. Now pay attention to this when I press enter. When we reached the question on what is your favorite food, well, our program skipped our user input and continued on with the rest of the code. So it states, hello bro, you are 18 years old, but we were not able to input anything for our favorite food. Here's the reason why. Here's what's going on. Let's pretend that this box is a representation of our scanner, and we're going to use the next line method of our scanner to read a line of text. So we type in our name and then press the enter key to submit. So this \n is an escape sequence for a new line. The next line method will read an entire line of text and stop when it reaches a new line character. So after we call the next line method, our scanner is going to be empty. However, if we were to call a different method that doesn't read a new line character, such as nextInt, so we type in our input such as the number 18 and then press the enter key, that will add a new line character. So our nextInt method is only going to read this numeric portion of our scanner, and then when we submit it, well, this new line character is still going to be within our scanner. And if we were to use our scanner again and call a different method like nextLine, well, our next line method thinks that we're at the end because there's this new line character within our scanner. So we would need some way to clear out that new line. One easy fix for this is that after you call the nextInt method, what we could do is call the next line method to clear our scanner. So I'm just going to copy this portion and paste it. We're not really going to do anything with that new line character. This will just clear the scanner for us. So now we should be able to answer all three questions. So type in your name. What is your name? It is bro. How old are you? Let's say I'm 18. What is your favorite food? And you can see that it paused this time, unlike the first time. And my favorite food is pizza. Press enter. Hello bro, you are 18 years old. You like pizza. Well then, that is one way in which you can use a scanner to accept some user input. Scanners are capable of much more. You can also use them to read the contents of a file and a few other things, but we'll learn about those in future videos. And if you need to use a scanner, be sure to include this import at the top. Import java.util.scanner, because the scanner class is found within the utility package, and then you'll need to create a scanner object just by following these steps. Scanner, you can call it scanner, equals new scanner. Well, guys and gals, that is how scanners work in Java. Before you go, I would greatly appreciate it if you could do a favor for me and like this video, leave a comment down below, and subscribe if you'd like to become a fellow bro. How's it going, everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about expressions in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Now, an expression is a combination of operands and operators. An operand is the values, variables, numbers, or different quantities that you might see in a program. And operators, they are those arithmetic symbols that you might see, such as the plus sign for addition, subtraction, multiplication, division, and then modulus. So let's go over a few examples just so that we know how they work. Let's say I have an integer variable called friends, and I will set this equal to maybe 10. So we can change the value of the friends variable by using an arithmetic expression. So let's say that we make a new friend, so we're going to add 1 to my variable of friends. To increment my variable friends, I can just use the plus operator and then add a new operand to my variable friends. So if I would like to assign a new value to my friends variable, I'm going to type in the name of my variable equals friends plus 1 because we made a new friend. And then I will print the value of friends. So our friends variable now contains 11. So we could also subtract. Take a wild guess as to what's going to happen. We just lost a friend. Let's multiply. Let's multiply our friends by 2. And now we have 20 friends. And let's divide. We're going to divide our friends into 2. And we have 5 friends. Now the modulus gives you the remainder of division. So we have 10 friends. What if we had modulus 3? Well, that does not divide evenly. So we're going to have a remainder of 1 friend. It's kind of like in group projects where everybody has to get into a group of 3 and there's always somebody that's left over. Think of it that way. Although if our group of friends was divided into groups of 2, there would be no remainder because 10 divided by 2 equals 5 evenly and there is no remainder. So that's all what the modulus is. It gives you the remainder of any division that occurs. Now there is a shorthand to increment a variable by 1. So normally the long way of writing this out would be type in the name of the variable equals, because we're going to reassign a value, friends plus 1, right? Well, there's a shorthand way of incrementing this, and that is to use the increment operator, which is just plus plus and then a semicolon. So this will add 1 to a value. And now we have 11 friends. If you want to decrement, that would be minus minus. And now we have 9 friends. Hold up, wait a minute. Before you go, I gotta discuss integer division because I forgot to talk about it. So if we divide a number by an integer, if there is normally a remainder, well, our program is going to truncate the remainder. Here's an example. Let's say we have 10 friends and we're going to divide our friends by 3. So we're dividing by a whole integer, so our result should be 3.33 repeating, right? Wrong, it's 3. That's because with integer division, we truncate any decimal portion because we cannot store it. One easy fix for that is we can cast our result as a double value or a float as well. To cast a value as a different data type, to the left-hand side of our expression, we're going to list the new data type that we would like to convert this value to. So we would like to convert our integer as a double value because we would like to retain that decimal portion of our result. However, our data type, friends, is an integer, so it cannot store a double data type. So we should probably convert this to a double so that we can store this value. And now this program will successfully store this decimal portion of our expression. Well, that's really all you need to know to get started with expressions. If you would like a copy of all this, I will post this in the comments down below. And if I could ask for a favor of you guys, just to like this video, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how we can make a very basic GUI application in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys and gals, I'm going to teach you all how to create a very basic GUI program. GUI is an acronym for Graphical User Interface. It's a visual program that we can see and interact with, kind of like this. So we'll be using the JOptionPane class and be creating a few message dialog boxes. Before we begin, we'll need an import. So outside of your class, let's type this: import javax.swing.jOptionPane. So we will be working with the JOptionPane class. Now, what we would like to do is type in some user information into a sort of dialog box, and we'll store this as a string variable called name, kind of like what we did on the video on user input. String name, and in order to create an input dialog box, we're going to type the name of the class, JOptionPane, dot, and there's a few options. What we would like is show input dialog, and you can really just pick any of these, and we can type in a message. So with this message, let's state, enter your name. And when we run this is what we have. We have this small GUI dialog box, and we can type in our name and submit it. But it currently doesn't do anything. So let's create another message dialog box that will display our name along with a message. So JOptionPane.show message dialog. For now, you can just type in null, comma, and then a message. Let's say hello plus name, and let's try it. So our first dialog box is the show input dialog message, and we can type in our name and submit a name. And our second box here is a message dialog box. This just displays some information, such as a string of text, and it says, hello bro. This time, let's ask for an age and store this value within an integer variable called age. Int age equals, and we can just copy all of this, JOptionPane.show input dialog, and the message will be enter your age. There is one issue though. When you use the show input dialog box, it's going to return a string, and we're attempting to assign the string into an integer variable. So what we would need to do is convert this to an integer, and there is actually a method to do that. So what I'm going to do is use the integer wrapper class and use the parseInt method, and within the parentheses we're going to take all of this and copy it within our parseInt method, and then add a semicolon at the end. So this will return a string based on what the user types in, and the parseInt method will convert it to an integer that we can store it within our integer variable of age, and then we can display this. So let's display this with another message dialog box. JOptionPane.show message dialog. Null will be the first argument, and our message will be you are plus age plus years old. And let's try it. Enter your name, bro, press OK, hello bro. Then when we click OK again, it's going to go to our next input dialog box. Enter your age, let's say that I'm 18, click OK, you are 18 years old. Now let's try this with a double data type. This time, let's create a variable called maybe height. This will be a double value, and the variable name will be height. So since we're working with double values, we're going to change integer to double with a capital D, dot parse double. And the message will be enter your height. And our message dialog will be you are height, and let's say this is in centimeters tall. So we have to be sure that we're getting the right data type, because when you use the input dialog box, it's going to return a string. So if you're attempting to assign that string to a certain data type, you have to convert it to that specific data type. So let's try this. Enter your name, bro, okay, hello bro. What is your age? Let's say I'm 18, press okay, you are 18 years old. Enter your height. I don't know what a good height is. 240 centimeters. And then click OK. You are 240.0 centimeters tall. In conclusion, ladies and gentlemen, what we have made is a very simple graphical user interface for fun. This is completely optional at this point, but we will be learning more about GUIs later in this playlist. So if you would like a copy of all this code, I will post all of this in the comments down below. And if you could do me a favor, down below, smash the like button, drop a comment, and subscribe if you'd like to become a fellow bro. How's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys a few useful methods of the math class. And at the end of this video, we're going to create a program where we will find the hypotenuse of a triangle. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Alrighty then, guys and gals, in this video I'm going to demonstrate a few useful methods of the math class. To begin, we'll need maybe two numbers. Let's say that these will be double variables, double x. Let's set this equal to 3.14 and double y. We will set this to, let's say, -10. Alright, the first useful method is the max method. This will find the larger of two numbers. So in order to use the max method, we're going to type math with a capital M, dot, and there's a few recommendations here. What we would like is the max method. That is right here. So there's a few to choose from. We can compare two integers, two long values, two floats, and two doubles. I'm going to compare the values of x and y. So I'm going to put these within the parentheses of my max method. And then we can either display the result or assign this to a new variable. Let's say double z equals math.max, and we'll compare x and y and assign the larger number to variable z. And we will display the result. System.out.println z. And the larger of these two numbers is, in fact, x, which is 3.14. And there is also a min method, which will find the lesser of two values, which is variable y, which is -10. Another useful method is the absolute function method. It's just ABS, like abs, six-pack abs. And we'll pass in y. And this will display the absolute value of y, which is 10. So the absolute value is basically a number without the negative sign. I'm not a mathematician, so I could be wrong in that definition. All right, we also have the square root function. That is sqrt. The square root of y. I don't know what the square root of -10 is, but we're about to find out. I don't know. I guess that didn't work. Let's change y to 10. 3.16, blah, 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 blah. All right, that is the square root function. We can also round. Let's round x. So x rounded is 3.0. On the other hand, seal, like ceiling, this will always round up. So 3.4 or 3.14 always rounded up is 4. And floor will always round down. So 3.14 always rounded down is 3.0. Here's a project that we can work on. Let's create a program that will find the hypotenuse of a triangle, and we will ask the user for side x and side y. So to begin, let's declare two variables, double x and double y. Actually, I take that back. Let's declare double z as well, because z will be the result, the hypotenuse. We'll also need a scanner to accept some user input. Scanner equals new scanner. Within the parentheses, we're going to type system.in. We'll need an import, so include this import at the top. Import java.util.scanner. We'll need a prompt for side x and side y. We can do that with a println statement. Enter side x. I can't type today. And we will store the result within variable x. X equals, we need some user input, scanner dot next double, because we would like a double value. Let's repeat the process for side y. Enter side y. We'll store the result within variable y. Now here's the tricky part. There is a mathematical formula to calculate the hypotenuse given two angles, well, two sides of a triangle. So this is what we're going to do. First, we'll multiply x times x plus y times y. Then we need to put this within the square root function of the math class. Math, make sure it's with a capital M, dot sqrt. And we are going to take all of this and place this within the square root function. And we will assign this to our variable of z. So z equals math.square root x times x plus y times y. And with a print line statement, we can display the hypotenuse is plus z. That should be good. Oh, then it's good practice to close your scanner. I always forget to do that, although it's not necessary. Scanner.close. All right, let's test this. Enter side x, that is 4. Enter side y, let's say 5. The hypotenuse is 6.4 and some change. All right, so that's just a simple program that you can make using a function of the math class. So if you would like a copy of this code, I will post this in the comments down below. But yeah, that's a few useful methods of the math class. Oh, and I forgot to tell you guys, like, comment, and subscribe. That is all. How's it going, everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how we can generate some random values in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Alright, welcome back, ladies and gentlemen. In this video, we're going to be generating some random values, some random integers, doubles, and Boolean values. So if you're interested in game design at all, this video is a must for you. So in order to use random values, we should probably import the random class found within the library. So outside of the class, this is what we're going to type. We're going to import java.util.random. semicolon. And now we have access to the random class, and that provides us a few options. We need an instance of the random class for us to use. Within the main method, we're going to create an instance of the random class by typing random with a capital R. It's the same name as the class, random. We need a name for this instance. Let's call it random, all lowercase, kind of like what we did with that video on scanners. Random equals new random. That's kind of random. Then a set of parentheses, then a semicolon. We now have access to this random instance to generate some random values for us. But there's a disclaimer here. These are not true random numbers, but something called pseudo-random numbers, which are pretty darn close. So I just wanted to give you that disclaimer before we got started, so you don't call me a liar. Let's generate a random integer and store this within an integer variable, like int x. Int x equals, and to generate a random integer, we're going to type the name of our random instance, random.nextInt. There's also a few others like next boolean, next double, next float. I'll get to those later. What we would like for now is nextInt. And then we will display the result with a print line statement. We will display the value of x. So the results are on a scale between, I would say, just under -2 billion to just over +2 billion. So you'll probably want to limit that. Let's pretend that we're going to roll a 6-sided dice. So to limit the scale or the size of the random number that we'll generate, we can pass in a value to our nextInt method. So within the parentheses of our nextInt method, we'll limit the size of the integer that's going to generate. If we would like a 6-sided dice, we're going to place 6 here. But there's one catch with this though. This will generate a random number between 0 and 5 because computers always start with 0. And let's see if I can roll a 0. Nope. There we go. All right, so one way to solve this is that if we want the numbers 1 through 6, we can just add 1. So now we'll get a random number between 1 and 6, just like that. This time, let's generate a random double value. For now, I'll turn this line into a comment, and let's create a new variable called double y. Double y equals random dot next, where is it? Double. And we will display the value of y. Next double is going to give us a random value between 0 and 1. So this probably has some uses for something. What that is, I'm not really sure, but hey, you know you can do this now. Let's also generate a random Boolean value. So Boolean z equals random dot next Boolean. And we will display the value of z. So this is going to give us either true or false. Well, everybody, that's how we can use the random class to generate some pseudo-random values for us. If you would like a copy of this code, I will post this in the comments down below. But yeah, that's a few uses of the random class. Also, be sure to leave a like, drop a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about if statements in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Alright, guys and gals, in this video we're going to talk about if statements. An if statement is a very basic form of decision making. When an if statement evaluates to be true, it will perform a block of code, and that is it. Here's an example. Let's say we have a variable called maybe age. Int age equals, let's set this to 18. We can perform a block of code if some condition that we state evaluates to true. So this is how to create an if statement. We type in the word if, a set of parentheses, and then a set of curly braces. So within the parentheses of the if statement, this is the condition. We can check to see if somebody is perhaps 18 or older. So what we can do is write a condition such as age is greater than or equal to 18. Within our program, when we reach this if statement, we're going to check to see if this evaluates to be true or false. Currently, our age is set to 18. So this will evaluate to be true, and we will perform whatever is within the set of curly braces. So let's print a message such as, you are an adult. And let's test this. So our age is 18, our if statement evaluates to be true, and therefore we will perform this block of code associated with this if statement, and we will display the message, you are an adult. What if we change this to maybe 12? And then with our if statement, when we reach this condition, this will evaluate to be false. Therefore, we will skip this block of code as if it never even happened. We could perform a different action instead. We could write an else statement. There is no condition. We just need the word else followed by a set of curly braces. Now we are forced to take one of two actions. We will check to see if our condition is true. If it is true, we will perform this block of code. If it's false, we will instead perform this block of code. So let's print a different message. You are not an adult. So we are forced to perform one of two actions. If our condition is true, we will perform our if statement. If it's false, we will perform our else statement. And this states that you are not an adult. Now, it is entirely possible to check more than one condition before reaching an else statement, and that is by using what is called an else if statement. So we type else if, a set of parentheses, and then a set of curly braces. So we can check an additional condition before reaching our else statement. So let's check to see if our age is greater than or equal to 75. All right. And then we will print a message such as, okay, boomer. So pay attention to this. Let's change our age to 75 and run this. All right. Well, it displays you are an adult. That's because our if condition evaluates to true because 75 is greater than or equal to 18. So it's going to skip everything else and ignore these blocks of code and continue on with the rest of the program. So if we want to first check to see if somebody's age is greater than or equal to 75, what we could do is move this to our if statement, and I'll just switch these around and change our else if statement to 18. So we'll first check to see if somebody is greater than or equal to 75. If they are, we will first print OK Boomer. Else if their age is greater than or equal to 18, we will display you are an adult. And let's try this again. And it displays OK Boomer. So you can see that we got an entirely different result with these if statements. If the condition evaluates to be true, it's going to perform its own block of code and skip everything else. You can check more than one condition by adding else if statements. We could check one more thing perhaps. Else if age is greater than or equal to 13, then we can display another message such as you are a teenager. And if we changed our integer variable age to 13, this will display you are a teenager. There is one thing that you should know. These symbols, the less than sign, the equal sign, the greater than sign, these are known as comparison operators. So they work normally as what you would imagine. However, if you want to compare if something or some value is equal, you don't use one equal sign. That's using the assignment operator. So we're attempting to assign our variable age equal to 75. If we need to compare if something is equal, we use two equal signs. So that's just one thing that is specific for programming. So we can check to see if our age is equal to 75. And this time it will print OK Boomer. So that's all what an if statement is. It's a basic form of decision making for your program. If a condition evaluates to be true, then it will perform a block of code. If its condition is false, it will perform its else statement. Unless you have else if statements, then it's one by one going to check to see if these conditions are true before reaching the else statement. Well, ladies and gentlemen, that's the basics of if statements. If you would like a copy of all of this code, I will post this in the comments down below. And if I could ask a favor of you, I would greatly appreciate it if you smash the like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about switches in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Okay, welcome back, ladies and gentlemen. In this video, I'm going to explain how switches work. A switch is a statement that allows a variable or other value to be tested for equality against a list of values. So if you find yourself in a situation where you're using a lot of if statements back to back, it's probably more efficient to use a switch statement instead. Here are the different data types that we can use to test for equality within a switch. And according to this description, one thing that we can check is the equality of a string. For this program, let's test to see if a string, let's say it's going to be a day of the week, is equal to a list of days of the week. If there's a match, we can display a custom message. So let's say string day equals maybe Friday, because I like Friday. And we will create a switch to see if our day equals a certain day. So this is how to create a switch. Type in the word switch, a set of parentheses, then a set of curly braces. Within the parentheses, we're going to list the value or the variable we would like to test for equality against a listing of cases. So our first case will be Sunday. This is what we're comparing our value or variable to. We're going to compare this variable to our case. So type in the word case followed by the value, colon, and if there is a match, what would you like to do? So I would like to perform a print line statement that states, it is Sunday. And then this next part is important. It's important to add the keyword break, so we break out of the switch and continue on with the rest of our code. So let's create another case for Monday. So I'm going to copy and paste, change Sunday to Monday, and I will print it is Monday. So I'm going to repeat this process a few times. And it's done. So I have a case for each day of the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and I have a corresponding print line statement for each day of the week: Sunday, Monday, Tuesday, so on and so forth. So with our string of day, we're going to place this within the switch statement to compare it for equality against a list of values. One by one, our switch is going to evaluate our day against each case. If there is a match, it's going to perform this subset of code. If there is no match, it's going to continue down to the next case and check to see if these values are equal. So let's test it. Currently our day is set to Friday, so this should display it is Friday. All right, so let's change this to Monday next. And this will display it is Monday. All right, this is why it's important to have these breaks after each case. So I'm going to remove this for this demonstration and show you why these are important. So if we were to run this again, this time we do not have those breaks. As soon as there is a matching case, we will perform this subset of code, as well as each subset of code that comes after our matching case. So that's why it's important to have these breaks within, well, after each case within our switch. So what if there is no match? Let's say our day is equal to pizza, which is not a day, but honestly, it really should be. Well, it will basically just do nothing. So one thing that we could do is add a default. Default, colon, if there is no match, what do we want to do? System.out.println, that is not a day. So let's try this again. If there is no match within our switch, we will perform whatever is set within the default case, which displays pizza is not a day. So that's all what a switch is. It allows a variable or other value to be tested for equality against a list of values. If you find yourself in a situation where you're using a lot of if statements, it might be better to use a switch instead. So that's all about switches. If you would like a copy of this code, I will post this in the comments down below. Please be sure to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video we're going to discuss the three logical operators: the AND, the OR, and the NOT logical operators. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, let's discuss logical operators. These can be used to connect two or more expressions, and there are currently three that I'm going to discuss. The AND logical operator, which is two ampersands, the OR logical operator, which is two straight bars, and lastly the NOT logical operator, which is an exclamation point. Let's begin with the AND logical operator. We can check to see if two or more conditions are true. If both conditions are true, an entire statement will evaluate to be true. Here's an example. Let's say we have an integer called temperature, temp for short, and we'll set this to 25 degrees Celsius. Let's write an if-else if statement to check to see what the temperature is and display a message based on the result. So let's check to see if our temp is greater than 35. Actually, let's make that 30. If temp is greater than 30, then we will display it is hot outside. So how can we check to see if our temperature is within a certain range? Well, we could use the AND logical operator to do so. Next, let's write an else if statement, and this time we're going to have two conditions, not just one. So first, we'll check to see if our temp is greater than or equal to, let's say, 20. And we would like to check to see if our temp is less than or equal to 30. So in order for this statement to be true, both conditions must be true. That's why we're using the AND logical operator. This side, as well as this side, both of these conditions need to be true for this entire statement to evaluate as true. So if our temperature falls within this range, let's display a message. It is warm outside. And then else, it's cold outside. System.out.println, it is cold outside. And let's try it. So currently our temperature is 25, and when we run this, it displays it's warm outside. If our temperature was 35, then it's going to display it is hot outside. If it's less than 20, well then this portion is going to evaluate to be false, but this portion will evaluate to be true. So therefore, this entire statement will be false then, since both conditions must be true. So if our temperature is 15, which is cold, it's going to display it is cold outside. That is the AND logical operator. For a statement to be true, both conditions must be true. Next up to bat, we have the OR logical operator. This will check to see if one or more conditions is true. If at least one of the conditions is true, then the entire statement is true then. So do you remember those old computer games like Oregon Trail where you usually had to type Q to quit the game? Well, let's replicate something like that via a scanner. So let's accept some user input. Scanner equals new scanner. Within the parentheses, system.in, and we will need an import. Import java.util.scanner. So we will ask the user if they want to quit the game, and in order to do so, you have to press either lowercase q or uppercase q, but we'll need a prompt first. You are playing a game. Press lowercase q or uppercase q to quit. And we will store our answer within a variable. Let's call this response. String response equals scanner.next. Next, we'll store the next key that you press within a variable, a string variable. So let's check to see if our response is equal to lowercase q or uppercase q. If, then within the condition of the if statement, our response, and with strings, to check to see if two strings are equal, you need to use the equals method. It's a little bit different with strings. If our response is equal to lowercase q, we're going to use the OR logical operator. If our response is equal to uppercase q, then that means the user wants to quit the game. You quit the game. Else, they still want to play the game, so we'll print a different message. You are still playing the game. Pew pew. And let's test this. You are playing a game. Press Q or Q to quit. So I'm just going to type no, and it says you are still playing the game. But you know what? This game is kind of lame, so I'm going to press lowercase q to quit. It states you quit the game. On the other hand, I could have pressed uppercase Q to quit the game, so let's try that. Uppercase Q, you quit the game. So with the OR logical operator, as long as one of these conditions is true, then this entire statement will evaluate to be true. And last but not least, we have the NOT logical operator, which is represented by an exclamation point. This will reverse the Boolean value of a condition. So using the NOT logical operator, we could make some changes to how our program is written. So if we precede these conditions with the NOT logical operator, this will reverse the Boolean value that these evaluate to. So we're checking to see if our response is not equal to Q, or our response is not equal to uppercase Q. And then we should probably change this middle logical operator to be AND. So if our response does not equal lowercase q and our response does not equal uppercase q, then that means this person, this user, still wants to play the game. Else, they are going to quit the game. So this will work much the same. You are playing a game, press Q or Q to quit. No, because this is a fun game. On second thought, this game is in fact kind of lame, so I'm going to press Q to quit the game. You quit the game. So that is what the NOT logical operator is. If you precede something with the NOT logical operator, it's going to reverse the Boolean value based on what it's going to resolve to. So in this case, we check to see if our response does not equal lowercase q and our response does not equal uppercase q, then this person still wants to play the game, else they're going to quit the game. So those are the three logical operators: the AND logical operator, the OR logical operator, as well as the NOT logical operator. If you would like a copy of all this code, I will post everything in the comments down below. Please be sure to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about while loops in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Alright guys and gals, let's talk about while loops. A while loop executes a block of code as long as its condition remains true. It's like an if statement, but it will continue that block of code continuously as long as its condition remains true. Here's an example. Let's create a program that will ask somebody for their name. If they attempt to not type in anything, well, we'll keep on prompting the user to type in their name. The only way for them to escape the while loop is to type in something, aka their name. So let's create a scanner. Scanner equals new scanner. Within the parentheses, system.in. We'll need an import, so be sure to include that at the top. Import java.util.scanner. We'll need a name variable. String name equals, and we'll just set this to a pair of quotes for now. This is how to create a while loop. Type while, then you need a set of parentheses, and then a set of curly braces. It's kind of like an if statement. We'll put our condition within the parentheses. If this statement, this condition remains true, then we will execute this block of code continuously until our condition is no longer true, until it evaluates as false. This is our condition. Name dot is blank. If somebody attempts to skip the process of entering their name, it will keep on prompting the user to type in a name. So let's create a print line statement. Actually, I'm going to change this to a print statement. Enter your name. And we will store the result within our name variable. Name equals scanner dot next line. And when we escape the while loop, we will display a welcome message. Hello plus name. All right, that is it. Let's try this. Our program states enter your name. I'm not going to type in anything. I'm just going to hit enter. So you can see it keeps on prompting me to enter my name. Enter your name. No. Enter your name. No. This time I'm going to type in my name because I give up. Enter your name, bro. Therefore, our condition is now false because our name is no longer blank, and we have exited the while loop and continued on with the rest of our code. There is a variation of the while loop. It's called a do loop, and how we write this is that we move the condition to the end of the block of code, and preceding this block of code, we write the word do. So what makes this different is that with the do loop, we will always perform our block of code at least once, and then we check the condition after. So this will work much the same. However, we're always performing this block of code at least once. So the do loop is a variation of the while loop, but it works very similar. It always executes the block of code once. Compared to the while loop, it will first check the condition and then execute the block of code if this is true. So everybody, that is the while loop. If you would like a copy of this code, I will post this in the comments down below. Also be sure to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about for loops in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on people? Let's talk about for loops. A for loop executes a block of code a limited amount of times. Compared to a while loop could continue infinitely depending if its condition remains true. With a for loop, this will execute a limited amount of times. So before we even begin the for loop, we already know how many times that this for loop is going to iterate. So let's create a program for an example that will count from 0 to 10. We can do this with a for loop. So this is how to create a for loop. type in the word for, a set of parentheses, and then a set of curly braces. So with our parentheses, we add a condition along with two other statements. So there's three parts to this for loop. The first part is that we can declare a sort of counter or index. So we will declare int index, and we can set this equal to 0, and then add a semicolon. So what a lot of people do is that they shorten index to I. It's more shorthand. With our second statement, this is our condition. We would like to continue this for loop as long as I is less than or equal to 10, because we stated that for this program, we would like to count from 0 to 10. Now, this third portion, we will increment our counter I by 1 after each iteration. So our for loop, at least within the parentheses, has three separate statements. We declare a counter or index. We call it I, but it's not necessary. That's just a common practice. This is our condition. We will iterate this for loop as long as this condition is true, and then we can increment or decrement our index. Let's take a look at this. How many times is this for loop going to iterate? Well, it's going to iterate a total of 11 times because we're counting 0 as well. So let's test this. With a print line statement, we will display our index of I. So this will count from 0 to 10 and then stop. So let's do the reverse now. Let's start at 10 and count down to 0 and then display a message such as Happy New Year. So with our index, let's set this to 10 and change our condition to continue as long as I is greater than or equal to 0. And then with our index, we will decrement this by 1. And then when we exit the for loop, let's display Happy New Year. So we will start at 10, count down to 0, and display Happy New Year. Now, with this statement, we could increment this or decrement this by more than 1. If we wanted to count down by 2, we would write this as I minus equals 2. So now this will execute a total of, let's see, 1, 2, 3, 4, 5, 6 times. Another way of writing this for loop that is optional is that you can move this third statement to within the for loop. And this will work much the same as it did before. It's just an optional way of writing this. So that's what a for loop is. It's similar to a while loop, except that it will execute a limited amount of times compared to a while loop that could execute an infinite amount of times. With for loops, within the parentheses, there are a total of 3 statements: an index that you can declare, a condition, and then you can increment or decrement the index by a certain amount. So that is for loops. If you would like a copy of this code, I will post this in the comments down below. Please be sure to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how nested loops work in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey, what's going on fellow human beings? In this video, I'm going to explain nested loops. A nested loop is really just a loop inside of another loop. To best demonstrate this, let's create a program where we can set a number of rows and columns and display a rectangle of a particular symbol that we decide upon. So in order to create this program, we'll need a scanner. Scanner equals new scanner. Within the parentheses, we're going to type system.in. We'll need an import. Be sure to include this at the top. Import java.util.scanner. Let's declare a few variables: int rows, int columns, and a string called symbol, depending on the symbol we want to use. And for now, we'll just set this to a blank set of quotes. Next, let's create a few prompts. Enter number of rows, so we will let the user control the amount of rows that will be displayed, and we will store the result within our variable rows. Rows equals, and we need to use our scanner, scanner.nextInt. And let's repeat the process for columns. I will copy everything I have here and change rows to columns. Columns and columns. and we will let the user decide on what symbol they want to display. So within another print line, enter symbol to use. And we will store this within our symbol variable. I guess we could have declared this as a character as well, but it's probably easier if it's a string. Symbol equals scanner.next. Next will store our next token that we type until we hit space or enter. And then this is where the nested loops comes in. We're going to have an outer loop and an inner loop. Our outer loop is going to be in charge of the rows. Our inner loop is going to be in charge of the columns. So let's begin with the outer loop. This will be a for loop. For parentheses, then a set of curly braces. We will add 3 statements to the for loop. The first is our index. Int I for short for index, I equals 1. Then for our second statement, we're going to continue this for loop as long as I is less than or equal to the amount of rows that we have. And our third statement, we will increment our index of I by 1. Within this for loop, all we're going to do is display a print line, a blank print line. So this will move our cursor down to the next row to display the next row of characters. So this is where the nested loop comes in. We're going to create another for loop within this for loop. So we will make another for loop, for parentheses, curly braces. We'll need an index, but we cannot reuse the same one. So let's declare another index, and a common practice for a nested loop is to declare an index of j, because j comes after I in the alphabet, I suppose. So we'll set j to equal 1. That's the first statement. The second statement is that we'll continue this for loop as long as j is less than or equal to the amount of columns that we have. And lastly, we will increment our index of j by 1. Within the nested loop, all we're going to do is display our symbol. Make sure you do this with a print, not a print line statement. So we will print whatever symbol that we have. And that is it. That's it. Let's compile and run this. Enter the number of rows. I would like 4 rows and 5 columns. Which symbol would I like to use? Perhaps the $sign. Hit enter, and here is my rectangle. It has 4 rows, 1, 2, 3, 4, and 5 columns. 1, 2, 3, 4, 5. So what happened here is that our outer for loop is in charge of the rows. Our inner for loop is in charge of the columns. Once we enter the outer for loop, we're immediately going to add a print line just to move down to the next line. And then with the inner for loop, in order to escape the inner for loop, we need to complete all iterations of the inner for loop. So what we will do during each iteration of this inner for loop is print our symbol. And once we print our symbol an amount of times equal to the amount of columns that we want, we can escape the inner for loop. And once we complete our inner for loop, we can finish one iteration of our outer for loop, but we have to complete the process all over again for the next iteration of our outer for loop. So we will enter our inner for loop one more time and have to reset our integer j, our index, back to 1 and repeat the process for the next row, all the way until our outer for loop is complete, and then we can exit the program. So that's all what a nested loop is. It's basically anytime you have a loop inside of another loop. These don't necessarily have to be for loops. You can have any combination of for loops or while loops for this too. Well, ladies and gentlemen, that is one example of how a nested loop could be useful, but you may see these in various different types of contexts. So if you would like a copy of this code, I will post all of this in the comments down below. Please don't forget to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how arrays work in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Alright, welcome back ladies and gentlemen. In this video I'm going to explain arrays. An array is used to store multiple values in a single variable. That is it. They're really not that complicated, but they can seem kind of intimidating. So let's begin with a simple string variable called car, and I will assign this a value of Camaro. What I could do is that I could store multiple values within this single variable by turning this variable into an array. And these are the steps to do so. Next to the data type, I'm going to add a set of straight brackets. And then with the values, I'm going to surround the values with a set of curly braces. And that is it. And for fun, I'll rename this as cars because that makes more sense. So it would make more sense to name this something that is plural because it contains more than one value. So let's add a few other cars. Let's say I would like to add a Corvette and a Tesla. And that is it. That is an array of cars. So in order to access one of these elements, arrays have spots, kind of like parking spots, and they are called elements. So let's say I would like to access this first element. So I'm going to take the name of my array, which is cars, add a set of straight brackets, and then list the element number. So computers always start at 0. If I want to access this first element, I'm going to write 0. And I could reassign this. Let's say I would like to instead place my Mustang within element number 0. And let's print whatever is within the first element of our array of cars. Cars, straight brackets, 0. So this will print my string of Mustang. If I want to access the next element, so this is 0, element number 0, and the next one is element 1, then 2, so on and so forth. In my next element of my array of cars, we have a Corvette, and then a Tesla. So what happens if I attempt to access an element that does not exist? So let's put 3 here. Well, what we'll get is an array index out of bound exception because this array does not have this element, element number 3. It only has elements 0, 1, and 2. But I could add another element. Let's say I'm going to add a BMW to element number 3. So then we no longer get that error because our array has a total of 4 elements, 0, 1, 2, 3. One thing that you should know with arrays, when you assign values, they all have to be the same data type. They have to be consistent. For example, I couldn't add the primitive integer value of 1, 2, 3 because what this states is that this is a type mismatch, cannot convert from int to string. So if you have an array of strings, for example, you can only add strings. If this was an array of integers, well, I could only add integers then to this array. So you have to make sure that the data type of the values that you're adding are all consistent with the data type of the array. Now, there is an additional way to create an array, and that is by first allocating the amount of elements that we'll need and then storing the values later on in the program. So this is an additional way to write an array. We type in the data type of the array, straight brackets, the name of the array, we'll call it cars, equals new, the data type again, straight brackets, semicolon. Within the straight brackets, we'll assign how many elements we would like within this array. Let's say we would like 3. So we can assign a total of 3 strings to our array of cars. And let's do that. So later on in this program, right here's a good spot, we will assign each of the elements of our array of cars. So cars at element number 0 will equal my Camaro. And then cars at element 1 will equal a Corvette. And cars at element 2 will equal a Tesla. And then we can display each element of this array. So let's begin with cars at 0. This contains the Camaro, then the Corvette, and then the Tesla. So this is an additional way to write an array. We can first declare the amount of elements that we would like for this array, and then we could assign the values later on in the program. Before we finish this video, I'm going to explain how we can use a for loop to iterate through all of the elements of an array. Let's say we would like to display all of the elements of this array. So let's create a for loop to do that. For, a set of parentheses, and then a set of curly braces. With for loops, there are 3 statements. The first is that we need some sort of index or counter. So let's say int I equals 0. That is the first statement. For the second statement, this is our condition. We'll continue this for loop as long as I is less than our array cars dot length. And lastly, we will increment our index by 1. So let's display whatever is within our array of cars at element number I. So I is going to begin at 0, then after each iteration of this for loop, it's going to increment by 1. So when we run this, this will display all of the elements of our array of cars: Camaro, Corvette, and Tesla. All right, everybody, so that's what an array is. It's really just used to store multiple values within a single variable. If you need to access one of the elements of an array, you just list the name of the array and the element number in which you're trying to access. So if you would like a copy of this code, I will post all of this in the comments down below. Please don't forget to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain 2D arrays, also known as multi-dimensional arrays in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Alright everybody, welcome back. In this video I'm going to be explaining 2D arrays. A 2D array is an array of arrays. Think of a 2D array as having a number of rows and columns. That's how I think of it, at least. We're going to be assigning some cars, some car names, into each element of our 2D array. Think of it like a parking lot, and each element has a row and column, kind of like a parking spot number. So to begin, let's declare a 2D array and allocate some memory. So the data type will be string. Then for a 2D array, we need 2 sets of straight brackets this time. And then the name of the array, we will call this cars, equals new. The data type again, which is string, 2 sets of straight brackets. And then we will list the amount of rows and columns. So let's say this will be 3 by 3. 3 arrays, and each array is going to have 3 elements. So let's begin assigning some cars into our 2D array. Let's begin with row 0. So in order to access a certain element of our array, we type in the array name, and this time we will add 2 sets of straight braces. We would like to access element 0, 0. So this is row 0, column 0, equals, and let's assign a name of Camaro. Now we would like to access row 0, column 1. And let's assign a different car, maybe a Corvette. Cars at row 0, index 2, will equal maybe a Silverado. All right, we're going to move to row 1 now. Actually, I'm just going to copy what we have here, paste it. So we are now on row 1, column 0. And let's assign a different car, maybe a Mustang. And let's repeat the process. Just to speed this up, I'm going to do a little bit of copying and pasting. So we're within row 1, and then we have column 0, 1, and 2. And let's change some of these names. For row 1, column 1, I will assign a value of Ranger. And row 1, column 2, maybe F-150. Okay, so we are now within row 2, column 0. So I'm going to copy that. Change some of the values. Row 2, column 0, I will assign a value of Ferrari. We are now on row 2, column 1. I will assign a value of maybe Lambo for Lamborghini. And then lastly, row 2, column 2. And I will place a Tesla in this element. And there we have it. We have assigned all of the values within our 2D array. So let's display all of the elements of our 2D array using a nested for loop. So we will have a outer for loop in charge of the rows and an inner for loop in charge of the columns. So let's create a nested for loop. So this is the outer for loop. We'll need an index. Int, we'll call it I for index, equals 0. And then we will continue this for loop as long as I is less than cars dot length. And lastly, we will increment our counter, our index I, by 1. Within the for loop, let's add a blank print line just so that we move our cursor down to the next row within the console window when we display each row of cars that we have. Now we need an inner for loop to display each column, each element within each column of our 2D array. So we'll need an index. Let's call this int j because j comes after I. Set this equal to 0. That's the first statement. Our condition is going to look a little funky. We'll continue this inner for loop as long as j is less than cars at index I dot length. So this will take the length of our first row and we'll continue our counter, our index of j, as long as it's less than the length of our row that we're currently on. And then we will increment our index j by 1. Within the inner for loop, all we'll do is print our array of cars at element I for this first set of straight brackets and j. Cars at row I, column j. And then maybe I'll add a space just to separate these. And what we get here is that this will display our 2D array of cars that we have. Now there is an additional way to write this 2D array. Instead of allocating all of the memory for this 2D array, what we could have done is assign all of the values right away to this 2D array when we declared it. If you prefer to write it that way, this is what will change. Instead of allocating all of this space, all of the elements that we would like for this 2D array, we're instead going to assign all of the values. So let's get rid of this portion, and we're first going to assign all of the values within row number 0. This is our first array. So within our set of curly braces, we will add our Camaro, followed by our Corvette, and lastly, our Silverado. So this is row 1. It's its own array. We will add a second array for row number 1. The first row was row number 0. So in our second array of row 1, we have our Mustang, followed by our Ranger, and lastly, our F-150. Okay, that is array number 2, also known as row 1. We are now on row 2. So let's add another array. And we have our Ferrari, followed by our Lambo, and lastly, our Tesla. All right, and then with all of this, I'm going to enclose all of these arrays within another set of curly braces. Then I'll need to add a semicolon to the end. And just so that this is easier to read, I'm going to separate each array within a new line. So it should look something like this. That's good enough. Sorry, I'm very particular about the appearance. Okay, so this is our 2D array of cars that we have, and you can see that it will work much the same even if I remove all of these lines of code. The only difference is that we're assigning all of the values to our 2D array when we declare it. All right, everybody, so that is the basics of 2D arrays. It's really just an array of arrays. Think of it as having rows and columns. If you would like a copy of this code, I will post this in the comments down below. Please be sure to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys about a few useful methods of the string class. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Hey, welcome back, my good people. In this video, I'm going to explain a few useful methods of the string class. Now, as you know, a string is a reference data type that can be used to store 1 or more characters, and reference data types have access to some fairly useful methods. Let's begin by creating a string variable called name. String name equals, and let's assign this a value of whatever your name is. So let's type our name variable, dot, and here are all the methods that we have access to. I'll describe and explain a few of the more useful methods that you might be interested in at this level. So let's begin with the equals method. This will compare two strings to see if they are equal. So within the equals method, let's type another string. I'm just going to copy what I have for my name to make this easy. This will return a Boolean value, and we can do something with that Boolean value, such as use it for an if statement or anything else. So I'm going to store the result within a Boolean value. Let's call this result. Boolean result equals name dot equals, and then type in a string. And let's display what the result is. So our equals method is going to compare my two strings, my name variable and whatever string is within here. And this will return true. However, it is case sensitive though. If I made the b in my name lowercase, this will now return false. But I could instead use the equals ignore case method. And now, both of these strings, according to my equals ignore case method, is now true. Next on my list is the length method, and just to keep things simple, I'm going to turn this line into a comment, and I am going to create a new variable. So the length method is going to return an integer based on the length of a string. Int result equals name dot length. And this will return a value of 3 because we have 3 letters in my name, but your name might be different. We also have the char at method. This will return a single character. Char result equals name dot char at. And we list an index if we would like to access the first character in our string. That would be index 0. And the second position would be 1. The third position would be 2. Then you just continue on in that pattern. So the character at index 0 of my name is capital B. Then we have index of. This will return an integer. Int result equals name dot index of. This will find a character and return the index of where the method finds that character. So let's say I would like to find an index of capital B. So this will return the position. And we have a capital B at index 0. If this was O, lowercase o, that is at index 2. We can also check to see if a string is empty. This will return a Boolean value. Boolean result equals name dot is empty. So currently my name is not empty, and this will return false. Now if I got rid of my name and we just have an empty set of quotes here, this will return true because my name variable is now empty. So let me reverse that and move on to the next method. We also have the toUpperCase method. We can change all of the letters in a string all to uppercase. So this will return a string. String result equals name dot toUpperCase. Now my name is all uppercase, and there is also to lowercase. Actually, I'm just going to copy most of this, paste it, and change upper to lower. This will change all of the characters in my name all to lowercase, and now the B in my name is now lowercase. We can also trim some empty space before and after the string. String result equals name dot trim. So this will remove all of this empty space that I just added. The trim method will remove all of this empty space before and after my characters that I have. And the last method I have to show you guys is the replace method. This will return a string, and we can replace a character with another within a string. Name dot replace. And there are 2 values we need to place within the replace method. An old character and a new character that we want to replace the old character with. Let's say we would like to replace all O's with A's. So this will replace the O in my name with A. And now my name is Bra. Well, guys and gals, that is a few of the more useful string methods, but not all of the methods entirely available to you. If you type in a string variable, type dot, at least with Eclipse, this will prompt an entire list, and you can always read through some of the descriptions to see what some of these methods will do. So those are a few of the more useful string methods. If you would like a copy of all this code, I will post all of this in the comments down below. Don't be afraid to help me out and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about wrapper classes in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, welcome back guys and gals. In this video I'm going to explain wrapper classes. A wrapper class provides a way to use primitive data types as reference data types. Here are a few examples of primitive data types. They include, but are not limited to, booleans, chars, ints, doubles. There's still many more out there such as bytes, shorts, and floats, but here are a few of the more common ones that we've been working with. So notice that strings are not within this list of primitive data types. That's because strings are already reference data types. Now, reference data types have some advantages and disadvantages. A few advantages, for one, would include that they may contain some useful methods. For example, take the last video on string methods. The string class contains some useful methods, and strings are an example of a reference data type. Also, reference data types can be used with certain collections, and they can be used with, for example, array lists, which we'll learn about in the next video. And a disadvantage of reference data types over primitive data types, for one, is that reference data types are slower to access. If you need to get the value of a primitive data type that is enclosed within a wrapper class, it's going to take more steps. So if you're working with millions of numbers, well, it's going to take a lot more time and a lot more processing power to use reference data types compared to primitive data types, because primitive data types are a lot faster. So each primitive data type has a corresponding wrapper class, and there's a naming convention with these. For the wrapper class, the first letter is capital, and the entire name is, for the most part, spelled out. So boolean would be boolean with a capital B, char would be character with a capital C, int is integer with a capital I, and double is still double but with a capital D. So let's assign a few primitive data types and use the corresponding wrapper class to create a reference data type. So Java has this feature called autoboxing and unboxing. We can directly assign some primitive values to a wrapper class automatically, and here's the definition. So autoboxing is the automatic conversion that the Java compiler makes between primitive data types and their corresponding object wrapper class. So let's use autoboxing to assign a primitive data type, a few primitive data types, to each corresponding wrapper class. So let's begin with a Boolean value. So we're going to list the data type, and it's going to be the wrapper class. So Boolean with a capital B, let's call this variable A equals, and then we can just use autoboxing to directly assign a primitive value to this reference data type. So I'm going to say that Boolean A equals true, and that is it. And let's assign a few others. So we have character B equals, let's assign a character, maybe the @ symbol, integer C equals 1, 2, 3, and double D equals, let's say 3.14. And what we have done is created 4 reference data type variables: Boolean A, character B, integer C, and double D. And for fun, let's create a string variable as well. Let's say string E equals whatever your name is. So are you beginning to see a pattern here? Strings are already a reference data type. That's why the first letter in the string data type, when you declare a variable of this type, is capital compared to the primitive data type variables that we've been working with. So it's kind of like we've been using reference data types all along when working with strings. As we've discussed at the beginning of this video, reference data types have a few advantages and disadvantages, and one of the advantages is that each wrapper class may contain some useful methods, kind of like what we did with the string class in the last video. So we already have a string. Let's look at a few of the methods of Boolean wrapper classes. So type in the name of the Boolean variable A dot, and then here are all the methods that you have access to. The same thing goes with characters. Here's a bunch of methods you can use. Same thing with integers and doubles. So reference data types within the wrapper class, they have access to some useful methods that you can use for your program. Not only that, but you can use these reference data types with certain collections, and we'll be using them for array lists in the next video. So if you need to access the values within a wrapper class, well, there's a feature called autoboxing and unboxing. Autoboxing is the automatic conversion that the Java compiler makes between primitive data types and their corresponding object wrapper class. When we directly assigned some values to each of these reference data types, what we have done is autoboxing. We automatically converted these primitive values to the corresponding wrapper class automatically. But unboxing is the reverse. We can convert a wrapper class to its primitive value. So what I'm saying is that with unboxing, we can treat these reference data type variables as if they were standard primitive values. So for example, let's say if Boolean A is equal to true, then we will display this is true. So even though this is a reference data type, it will still behave as a standard primitive data type because of the unboxing feature. And the same thing goes with B, except B has to be a character. So let's check to see if this is equal to our @. And this is also true. So that is the unboxing feature. You can still treat these reference data types as if they were primitives. So even though there are a few advantages of wrapper classes over the primitive data type that they may contain, there is still the disadvantage that accessing the values contained within a wrapper class still takes a lot more steps compared to using just a raw primitive value. So if you're working on a program that contains millions of numbers, for example, using reference data types, using the wrapper class for each primitive value is going to take a lot more steps compared to just using a standard primitive value. So primitive values are a lot faster than reference data types. So everybody, that's the basics of wrapper classes. If you would like a copy of all this code, I will post all of this in the comments down below. Don't forget to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's Bro, hope you're doing well, and in this video I'm going to teach you guys all about array lists in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, well, welcome back ladies and gentlemen. In this video I'm going to be explaining array lists. An array list is a collection. It's a type of resizable array. Elements can be added and removed after the compilation phase, which you cannot normally do with standard arrays. However, they only store reference data types, and I'll give you a few examples. So these are the steps in order to create an array list. First, we type array list. Pay attention to the capitalization. The A and the L are both capital. Then we need a pair of angle brackets, and we're going to list the reference data type within the angle brackets. Let's say we're storing an array list of food. So we will create an array list that will store some strings for the names of food. Now, if you need to store primitive values like an integer, a double, a character, you need to use the wrapper class. So for example, if we needed to store integers within an array list, we would not place int, we would use the appropriate wrapper class and type integer. So we're going to be storing strings, which are already reference data types. So let's call this array list food equals new array list. Angle brackets, we're going to list the data type again of string, parentheses, semicolon, and we'll need an import. So at the top of our program outside the class, import java.util.ArrayList. We now have an array list called food that will store strings. So how can we add values to our array list? Well, there is a function to do that. That is the add function. And in order to use the add function, type in the name of the array list dot add, and we can add a string. So let's add a few food items. Let's add pizza to the first element, followed by, I'm going to copy this, hamburger, and hot dog. So let's display all the elements of our array list, and we can do that using a for loop. So for, parentheses, curly braces, and then we will need an index, int I. We'll set this equal to 0. We'll continue this for loop as long as I is less than food. And normally with arrays, you would use dot length, but with array lists, we use dot size. And we are going to increment our index by 1. And then in order to display or retrieve one of the elements of our array, we will use the get function. And let's put this within a print line statement, food.get, and then we are going to list the index of I. So this will display all of the food that is in our array list, pizza, hamburger, and hot dog. Now let's discuss a few useful methods of array lists. The first useful method is the set method, food.set. So we can set a value at a certain index. Let's say at index 0, currently we have pizza at this index. We will replace this value with maybe sushi. And now within our array list, if we display all of the elements using our for loop, we now have sushi, hamburger, and hot dog. So our pizza value has been replaced with sushi because we used the set method. So we can also remove a value at a certain index using the remove method, food.remove. Let's say we would like to remove our hot dog. That is at element number 2. And now we only have sushi and hamburger. And last but not least, we can use the clear method to clear our array list, food.clear. And we no longer have any elements within our array list of food because we cleared it. We ate all the food. All right, everybody, so that is array lists in Java. If you would like a copy of all this code, I will post all of this in the comments down below. Please don't forget to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to be teaching you guys about two-dimensional array lists in Java. So let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey everybody, so we're going to be discussing 2D array lists, and what this is that it's a dynamic list of lists. It's a list of separate lists. So you can actually change the size of these lists during runtime, so that's kind of an advantage of array lists over just standard arrays. So before we begin, make sure you have this import at the top. And what I'm thinking for this video is that we're going to create separate shopping lists, and at the end, we're going to add these separate shopping lists to an array list. It's going to be a list of separate lists. So let's create a array list for maybe bakery goods, like things we need to buy at the bakery at a grocery store. So we'll create an array list, and then we need some angle brackets. And then with array lists, these store objects, so we need to use the wrapper class of the data type that we're storing. So for example, if you need to store integers, you're going to use the wrapper class of integer. But let's store some strings because we're storing the names of things we need to buy. So let's call this array list bakery list. And we're going to set this equal to new array list. All right, let's add a few things to our bakery list. So bakery list dot add. And what do we want to buy? Maybe some pasta. And maybe 2 other things. How about some garlic bread? Everybody loves garlic bread. And donuts, because I like donuts. Okay, so we have an array list called bakery list, and it has these 3 items. We can actually display our bakery list by using a print line statement, and we're going to place our bakery list within here, and we have pasta, garlic bread, and donuts. Now, if you want to retrieve a certain element of this list, we use the .get method, and we specify an index. So 0 would be pasta. So let's create a few other lists. So I'm just going to copy this, and for the next list, let's have this be a produce list. So fruit and vegetables. So produce list, and we need to change this here as well. So we'll change bakery list to produce list for this next array list. And let's add some tomatoes. And what goes with pasta? Maybe some zucchini. And maybe peppers. Okay, and then we'll just add one more. So what about a drinks list? So we'll change produce to drinks. And let's say we only want 2 drinks. So these lists don't have to be the same size as each other because they're all independent lists. So let's say that we want soda and we want coffee. And let's display our drinks list. Oh, we should probably change this here as well. So make sure you do that. Okay, we'll display our drinks list, which has just soda and coffee. Now we have these separate array lists, one for each aisle of a grocery store. Well, at least just a few of them. So what we can do is actually add all of these separate lists to one list, and we can call it maybe grocery list. It will contain different lists of what we need to buy at the grocery store, and they're all kind of organized by their section. We have one for bakery goods, we have one for produce, and we have one for drinks. So let's create a 2D array list to contain these separate array lists. So what we're going to type is array list, and then within the angle brackets, we list the data type of what we want to store. And what we want to store this time is array lists of strings. So we're going to place this within angle brackets. So array list, and within the angle brackets, array list again, and this stores strings. So we need a name for this 2D array list, and the name should be descriptive of what it contains. So we'll just say grocery list, because it contains separate lists of things we need to buy at the grocery store, and they're all organized by section. So grocery list equals new array list. And then we need to add these separate array lists to our 2D array list. So what we're going to do is take our grocery list, and then we're going to add whatever lists that we want to add. So we need to add our bakery list, and we're going to do the same thing for our produce list and our drinks list. So we'll change bakery to produce. And then lastly, we need drinks. So drinks list. So then if we take our grocery list and then display this, what we end up seeing is that we get the total sum of everything that's within our grocery list, and they're all arranged by section or array list. You can see that they're all separated with a comma. So it's a list of lists. Now let's say that you want to retrieve just one list from this array list. Well, you can use the get function, and then you can retrieve something by its index. So let's say that we want the first list in this 2D array list. We're going to get index 0, and this will retrieve the first list. Now let's say that we want the first element of our first list. We're going to add dot get again, and then the index for the element of this inner list. So if we want the first element of the first list, we type in dot get 0 and dot get 0 again. And then when we run this, we have pasta. Now, if we want the last index, so this is, let's see, this is list 2, item number 1. So we'll write get to item number 1, and this retrieves coffee. So that's the basics of 2D array lists. It's just a container for separate array lists. You can do this with other collections too, but we've only really covered array lists. So if you want a copy of all this code, I'll post this in the comments down below. But yeah, that's how two-dimensional array lists work in Java. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about the for each loop in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Hey, what's going on, guys and gals? In this video, I'm going to explain the for each loop, also known as an enhanced for loop. This is a traversing technique to iterate through all the elements in an array or other collection. The benefits is that a for each loop takes less steps and is more readable than a standard for loop. However, it is less flexible. So let's begin by creating an array of animals. So these will be animal names, so the data type will be string. Then we need a set of straight brackets. We will call this array animals equals, and then we will assign a few values. So within our array of animals, let's say we have a cat, a dog, a rat, and a bird. I'm not sure what kind of bird, just use your imagination. Now we could create a for loop to iterate once through each element of this array, but we could also use a for each loop to do this. So this is how to create a for each loop. Type for, a set of parentheses, and then a set of curly braces. So the only part that is different is the statements within the parentheses of the for loop. We're going to begin by listing the data type of our array or other collection. So we're going to list this as string because we're iterating through strings. Next, we need an index. Let's say index I, then colon. Colon represents the word in. For every string index in our array of animals. So lastly, list the array or collection name at the end. So this will iterate once for each index in our array of animals. So what would we like to do within each iteration of this for each loop? Let's display whatever I is. So this is going to be a string, whatever this data type is, so we can print this directly. And when we run this, our for each loop will display all the elements within our array. And now let's try this for each loop using a collection. An array list is a type of collection, so let's create an array list called animals this time. So array list, within angle brackets, we're going to list the data type, which is string, and then we will call this animals equals new array list, angle brackets, list the data type, parentheses, semicolon, and then we'll need an import at the top, import java.util.ArrayList, and then we need to add some values to each element of this array list. Animals.add, we're going to add a cat, then repeat the process for dog, rat, and bird. Dog, rat, and bird. And you can see that nothing has changed. So remember, a for each loop is useful for iterating through all of the elements in an array or other collection. It involves less steps and is more readable, but it's less flexible compared to a standard for loop. So that is everything you need to know to get started with the for each loop, also known as the enhanced for loop. If you would like a copy of all this code, I will post all of this in the comments down below. And don't forget to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain methods in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Alright, welcome back guys and gals. In this video I'm going to explain methods. A method is a block of code that is executed whenever it is called upon. For example, when we begin our program and execute it, we begin by calling the main method. That's where we've been writing a majority of our code. So anything within this set of curly braces belongs to this main method. This time we're going to create our own method that we can call whenever we need it. So outside of our main method, make sure you don't write this within the main method, we're going to create another method, perhaps a method that will display a message such as hello. And to begin creating a method, we'll need a return type. I'll explain return types later on in this video. For now, we're going to list the word void, followed by a method name. Our main method is called main, and a common naming convention for methods is to have the first letter lowercase. So let's create a method called hello. When we call this method, it will display a message such as hello. So this will be hello with a lowercase h, then we need a set of parentheses, and then a set of curly braces. Anything within the set of curly braces belongs to the hello method. And if we call the hello method, it's going to perform whatever code is between these two curly braces. So what would we like to do when we call this method? Let's display a message such as hello. Now within our main method, we can call, also known as invoking, this method. So within our main method, we can call the hello method whenever we want. Now we have just one issue that we need to take care of, and let me explain. We cannot make a static reference to the non-static method hello from the type main. So this means that we need to precede this method with the keyword of static, because we're calling the hello method from a static method of main right here. So normally we do not need to add this keyword of static, and if you want to learn more about things that are static, I do have a video on it. But for now, we just need to add this keyword in order for this program to work for this example. So when we call the hello method, it's going to perform whatever is within our block of code. And here it just displays the word hello. And we can call this method whenever we want and however many times we want. So if we want to display the word hello 3 times, we can just call the method 3 separate times. And this method will perform its task, its block of code, however many times it is called. One feature available to methods is that we can pass a value or a variable to a method when we call it. For example, we can pass a string variable to represent a name, and then we can use that name for something within our block of code. So for example, let's pass in a name of whatever your name is. Let's say bro. We can pass in a value or a variable. So for this example, I'm going to pass in a variable called name. String name equals bro, and I'm going to pass my variable of name into my method. So if you want to pass a value or a variable to a method, when you call that method, within the parentheses, just list all of the values that you would like to pass to your method. The values or variables that you're sending to a method are known as arguments, and they can be confused with what's known as parameters. In order to pass some values or variables to a method, when we declare our method, we need a matching set of what's known as parameters. Think of these as the rules. In order to call this method, we need a matching set of arguments and parameters. Currently, these are not matching. We're passing in a string, but there is no matching parameter. So this is how to set up a parameter for a method. We're first going to begin by listing the data type of the value that our method is expecting. So we're passing in a string as an argument. So we need a string parameter. So we need to first list the data type, followed by a name for this value. Just to make it simple, I'm going to call this name. So we now have a matching set of arguments and parameters. And now, since we're passing in our name variable to our method of hello, our hello method now has access to a string variable of name, and it contains this value of bro. So now we can use this name for something. Let's display hello plus name. And when we call this method and pass in our name, it's going to display the word hello plus our name. Hello, bro. So with parameters, you don't necessarily need to keep the names of the values consistent. I could change this name to something else, like title, I guess. And then I will switch that around, and this will work just the same. So these don't necessarily have to be called the same thing, the argument and the parameter. You can change the name if you want. Even something like this would work too. I don't know why you would write it like that, but you can. So with methods, you can pass in more than one argument as long as you have a matching set of parameters. This time, let's pass in an integer value. Let's create an integer variable called age. Int age equals, and I'll set this to 21 this time. So within my hello method, I'm going to pass in my name and age as arguments to my hello method. However, we have a problem. If I attempt to run this, we do not have a matching set of arguments, name and age, and parameters. We're passing in a string and an integer, and our method has parameters set up to accept only a string. So we need to finish setting up the parameters for this hello method so that the arguments and parameters match. So we need an integer, and we will call this age, and then we can use this age variable for something. So within another println statement, let's display you are plus age. And now this will work because we have a matching set of arguments and parameters. And before we finish this video, I would like to explain return types. We can return a value back to the area in which we called a method. So for this example on return types, I think this can be best explained with a separate example. So I'm going to clear out all of this and create a new example. Let's say we have two integer values. Int x, this will equal maybe 3, and int y, this will equal 4. Well, let's create a method that will add these two numbers and return the sum, the result of these two numbers. So outside of the main method, let's declare a method static. Normally we would type void if we're not returning anything, but if we're going to be returning a value, we need to list the data type of the value that we're returning. If we're going to add two integers together and return the sum, we're going to list the return type as integer because that's the data type of the value that we would like to return. We would like to return an integer, and then we will list the method name. Let's call this add, parentheses, and then a set of curly braces. So we cannot normally finish compiling this because if we're listing a return type, we need to list a return statement. What do we want to return? Well, we're going to return an integer, but we'll have to get to that later. So let's begin by setting up the parameters for our add method. Let's say we would like an integer. Let's call this x and int y. So in order to call the add method, we need to pass in two arguments, two integers. So let's call the add method and pass in our variables x and y. And within the add method, we will add these two numbers together. We could store this within a separate variable, int z equals x plus y, and then we could return our value of z. So when we run this, what's going to happen? Well, it doesn't display anything. That's because when we return the value of z to this area in which we called our method, well, we're not currently doing anything with this value. So we could store this within a variable or display it directly to the console window. So let's store the sum within int z equals add x and y. So you may have noticed that we declared this variable twice, int z within our main method and within our add method. This is technically legal because they are known as what's called local variables. Int z is only recognized by anything within the immediate set of curly braces. It's known as a local variable. Our add method does not recognize this int variable of z, so we could declare our own to use, or you can rename it too. It doesn't really matter what you do. So we can store the sum of our add method within int z and then do something with it, such as display it to the console window, system.out.println z. So this will display the sum of 7. Another way in which you could write this, we don't necessarily need to store the value in which we're returning to a variable. We could just directly display it to the console window too. So within my print line, I'm going to call the add method and pass in x and y, and this will still display 7. Another way in which we could shorten our method is that we don't need to store the sum within a variable. We could just return x plus y. So let me clear this line, and we could return x plus y, and this would be valid too. So that's another way of writing this. Well, everybody, those are methods. They are really just a block of code that is executed whenever it is called upon. You can pass in values or variables known as arguments, but in order to do so, your method, when you declare it, needs a matching set of parameters. And then you could return a value if you need to. Instead of using the word void, just list the data type of the value that you're returning. So if you would like a copy of all this code, I will post everything in the comments down below. And don't forget to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about overloaded methods in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. All right, everybody, let's discuss overloaded methods. Overloaded methods are methods that share the same name, but they have different parameters. This is allowed because each method needs its own unique method signature. That is the method's name plus its parameters. They can share the same name, but they would need different parameters to give them each a unique method signature. Let's create a few overloaded methods, perhaps just a few add methods that will add some numbers together. Outside of our main method, let's declare a few overloaded methods. So for this example, we'll need these to be static. Let's return an integer, so the return type is going to be int, and this will be called add. And we will accept a few arguments, so we need to set up some corresponding parameters. Let's say int a and int b. And we will return the sum, return a plus b. So let's create another method, an overloaded method, also called add. wait a minute, we have a problem. So we have two methods that are duplicates. Duplicate method add in type main. They both have the same method signature. They both share the same method name as well as the same parameters where they accept two integer values. There are two ways in which we can resolve this. The first is that we can change one of the method names and this error would go away, but that defeats the purpose of overloaded methods. The other way is that we can change the parameters that we have for each method. Let's say we would like two versions, maybe even three versions of our add method. One that accepts two values, another that accepts three values, let's say int c, return a plus b plus c, and another that will accept four values. So we'll have int d, return a plus b plus c plus d. And then our problem went away. So let's test these. I'm just going to add a print line that states which overloaded method we're using. This is overloaded method number 1. And I'm going to copy this and paste it. And we'll change the second instance of this print line to this is overloaded method number 2. And lastly, this is overloaded method number 3. So let's try this. Let's say we have an integer, int x equals add, and we can pass in between 2 and 4 integers. Now I'm going to attempt to pass in a single integer value, but we cannot run and compile this because we do not have a matching method signature. We can pass in between 2 and 4 integers. So let's try this by passing in 2 arguments this time, 2 integer values, and then let's display the sum, the result. System.out.println, our variable of x. So we end up using our first overloaded method. This is overloaded method number 1, and this will display the sum, a plus b, which is 3. And let's try and use our second overloaded method. We need to pass in 3 integer values as arguments, and we are now using our second overloaded method. And lastly, we can pass in 4 integer values, and we end up using our third overloaded method, and we get a sum of 10. And with overloaded methods, not only are the numbers of parameters taken into account, but the data type for each specific parameter. So this time, let's create 3 more add methods, but these ones will accept double values instead of integers. So let's change any instance of int to double, including the return type. All right, and then I'm going to change the number of the overloaded method that we're using. So 6, 5, 4, 3, 2, 1. Our first 3 methods only accept integers, and they will accept between 2 and 4 integers. Our next 3 add methods only accept double values, and they accept between 2 and 4 double values. So we could also pass in some double values to our overloaded methods. Let's change these to 1.0, 2.0, 3.0, and 4.0. And we will need to change the data type of our variable x as well. So double x add 1.0 through 4.0. And we are now using overloaded method number 6, which accepts 4 double arguments. In summary, overloaded methods are methods that share the same name but have different parameters. They can share the same name, but they would need different parameters to give each method a unique method signature. Some factors that are taken into account with parameters are the number of parameters, the data type, and the order of the values. So if you would like a copy of all this code, I will post all of this in the comments down below. Please don't forget to help me out and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys all about the printf method in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Hello all, welcome back to another video. For this topic, I'm going to be explaining the printf method. This is an optional method to control, format, and display text to the console window. Here's an example of the printf method, and this is different from print and print line. With the printf method, there are two arguments we need to place within the parentheses of the printf method. The first is a format string, a string that you would like to display to the console window. And second, we can add either an object, a variable, or a value. To keep it simple for now, I just added a value of 1, 2, 3. So we can format some value and place it at some position within the string. The position in which we want to add this value, whatever it is, can be added to wherever we add a format specifier, which is represented by a %sign. Let's say we would like to add this value at the end of our format string. So we would add a format specifier at the end that is represented by the %sign. And there is a certain amount and number of combinations and characters that we can add after this format specifier, and this will format our value a certain way. If we simply need to display a decimal number, we're going to add a D. It's kind of like a secret code. That's how I think of it, at least. So if we add a %sign and D, we will add this decimal value at this position within our format string, and that will appear down here. I could place this format specifier someplace else, and this value would be added to wherever I put this format specifier. So if I added this format specifier to the beginning of my format string, then this value will appear at the beginning of my string. So with the printf method, you need a format string and either an object, a variable, or a value. Depending on where you place this format specifier, the %sign, your value or variable will appear at this location. Think of it as you're replacing the format specifier with this value, and depending on the combination of flags, numbers, and characters after this format specifier, this is going to format and display your value a certain way depending on what combination of letters and characters comes after. Let's begin with conversion characters. This is a letter that appears after the format specifier, and the conversion character corresponds with the data type of the value that we're attempting to add. So D corresponds with decimal numbers, so we could add an integer at this location. So let's go over a few of the conversion characters that are available to us, but we'll need to create a few variables to do so. So let's begin with a Boolean. Let's call this my Boolean, and I will set this to true. We'll need a character, so let's say char my char equals, and then pick a symbol that you want to use. We'll need a string my string equals maybe your name. We'll need an integer, int my int, and assign it a number. I'm just going to pick one at random, let's say 50. And let's add a double value. So double my double equals maybe 1000. Okay, so these are not all of the data types that are available to us, but a few of the more common ones for beginners. So let's use the printf method and cover a few of the conversion characters. So we will need to use the printf method, system.out.println, printf, and let's just use the format specifier. So if we need to display a Boolean value, that would be % then B for the conversion character to display a Boolean. And we need to add a second argument. That is the value that we're attempting to add. So let's add my Boolean. And we can now display whatever this value is. So for characters, that is actually %C. And let's display my character. Okay, so strings are %S. So let's copy this, paste it. That is %S. And this will display a string. Should probably get rid of that line too. Okay, and integers are D for decimal, but we've covered that already. So %D for a integer. Let's display my int, which displays 50. And %F for a double value. So that's for floating point numbers and double values. So let's display my double. So remember, with conversion characters, these are certain letters that follow the format specifier, the %sign, and in order to display a certain object, variable, or value, you need a matching conversion character to follow after the format specifier. B for booleans, C for characters, S for strings, D for integers, and F for floats or doubles. Our next field is the width field, so I already created some notes on this. The width field sets the minimum number of characters to be written as output. So here's an example. We have a format string, and we would like to display a value that is of the string data type. So let's say at the end, we're going to add %s to display the string. We can set a minimum number of characters to display. So let's say we want to display at least 10 characters for this string. So before the conversion character, we can set a width, and this is a number. So if we want 10 spaces worth of room to display this string, we would add 10 or some other number before the conversion character. So before we display this, I'm just going to turn these lines into comments, and we will display hello plus my string, which states bro. So this prints a minimum of 10 characters for the name, including the length of the name. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the space that was here already too. So you can set a width, and this will display a minimum number of characters to be written out. And if you set this to be a negative number, that's actually a flag that we'll get into in just a little bit. That'll actually left justify the text within the space that we're allocating to display this value. So this text is now left justified, but all of that empty space now comes after my text, my string. Next on our list is the precision field, and what this will do is set a number of digits of precision when outputting floating point values. These include the data types of floats or doubles. Here's an example. I have a format string that states you have this much money, and then we have a format specifier that will display my double. This is the default, so we need at least %f, and this will display 1000 as well as 6 zeros after our decimal. We can limit the amount of digits that will display after this decimal by using the precision field. So we write this before the conversion character. Let's say we would like to limit the amount of digits that we have after this decimal to 2 to represent cents. So I'm going to add 0.2 for 2 digits. And this will limit the amount of digits that will appear after the decimal portion. And if we change this to a different number like 1, well then this will only display 1. So that is the precision field. It will set a number of digits of precision when outputting floating point values. And lastly, we have flags. These will add an effect to output based on the flag added to the format specifier. Here's a few. We can left justify, we can output a plus or minus sign for a numeric value, we can have numeric values be padded with zeros, and we can separate large numbers by the thousands by using a comma. Let's try a few of these out. Let's copy what we have for our example for precision. So I'm going to copy this line, and let's get rid of the precision. So we have %f. Let's left justify this. So I'm going to set a width, maybe 20, and set this to negative. So this will left justify all of that. Although it's a little difficult to see, I'm going to get rid of the left justify, and this will now be right justified. So this would be useful if you need to line up a bunch of numbers. We can output a plus or minus sign for a numeric value. So I'm going to add +f, and this should be plus 1000. If this was a negative number, like negative 1000, this should appear as a minus now. We can also pad our number with zeros. So let's set a width of maybe 20, and we will right justify it, so we do not need a negative sign, and we are going to add 0. So we now have a bunch of zeros before our number of 1000. And lastly, we can separate each thousands place with a comma simply by adding a comma as the flag. So %, f. So at the 1000s place, we now have a comma. So that is all what the printf method is. It's an optional method to control, format, and display text to the console window. We need at least two arguments, a format string, as well as either an object, a variable, or a value. We can add a format specifier within this format string and add a combination of characters and numbers to format our variable, value, or object a certain way. So that is an intro, more of a crash course to the printf method. If you would like a copy of all this code, I will post everything in the comments down below. This video was a lot of work. Feel free to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. How's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys about the final keyword in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Okay, ladies and gentlemen, I'm going to be teaching you guys about the final keyword. Anything that is declared as final cannot be changed or updated later in your program. Here's an example. Let's say we have a double variable called pi, and we will store the first few digits of pi, 3.14159. There's still more digits than that, but that's good enough for this example. And let's update the value of pi to maybe 4. And then within a print line statement, let's print the value of pi. So this will display 4 because we updated our variable pi to equal 4. So if we were to use the final keyword, when we declare our variable, we're going to precede our data type with the keyword final. And we can no longer update this value, and it states the final local variable pi cannot be assigned. It must be blank and not using a compound assignment. So we can no longer change the value of pi. We're going to run into a problem, and it states here that we ran into an unresolved compilation problem. So if you declare anything as final, you cannot update it. It is final. That's the law. You can't update it. And one common practice that people will do when they declare something as final is that with the variable name, they will make all the letters uppercase. It's not necessary, that's just common practice. And when we run this program, it displays our number pi of 3.14159. So really, that's the basics of the final keyword. Anything that is final cannot be changed once you declare it. If you would like a copy of this code, I will post this in the comments down below. But yeah, that's how the final keyword works in Java. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys all about object-oriented programming in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey, welcome back. This video is the start of the object-oriented programming portion of the series. The abbreviation people use is OOP, also pronounced as OOP. Now, objects, they can be intimidating, but they're really not that bad once you get to know them. So look around you right now. You are surrounded by different objects. Next to me, I have a phone, a desk, a computer, and a coffee cup. And you can hear me knocking on it right now. Unfortunately, it's empty. So we can use programming to imitate objects in the real world. Anything you can think of, really. An object uses a class. For example, I have a class called car, and we're going to be constructing some car objects. So with objects, they contain attributes and methods. Think of attributes as the characteristics that this object has, and methods as the different actions that this object can perform. For example, let's list some of the attributes of a coffee cup. These are the characteristics of my coffee cup. So for example, let's say that the color of this coffee cup is white. I could store this within a string variable within the class called color. And we can assign this a string value such as white. What about a temperature? That could be a double variable, and let's say that this is room temperature at 20 degrees Celsius. And then what about a status like if it's empty or is it full? This could be a Boolean value such as true or false. And unfortunately, my coffee cup is empty, so empty will equal true. Now, what kinds of methods, what kinds of actions can this coffee cup perform? Let's say we have a drink method, and when we call this method, we can print a message such as, you drink from the cup. Or what about a spill method? if we were to call the spill method in case I decide to spill my coffee everywhere, we could say you spilled your coffee everywhere. So all an object really is a bundle of defining attributes and methods, the characteristics of an object, and what actions that this object can perform. And for today's video, we're going to be creating some car objects. Why? Because, well, I like cars. So we need to create a different class, another class. So you can either do this within the same Java file or a separate Java file. So if you were to create a class within the same Java file, make sure that you declare this class outside of the main class that you're working with. But I like to keep my code organized into different Java files. So for me, I'm going to create another Java file. So within my project folder, I'm going to go to File, New, Class, and I'm going to call this class car because we're constructing car objects, and then click Finish. So I have two classes within my project folder, one called main, for you it may be named something different, and a car class. So we're going to be using this car class to define the attributes and methods of what our cars should have. But if you decide to write this within the same Java file, you'll probably write something like this, but I'm just going to keep these as separate files. Now, what kinds of attributes should our car have? Let's start defining a few. Let's say a make and model. These could be string variables. So let's say string make and pick one of your favorite cars. Let's say string make equals Chevrolet. And we could also have a model like string model equals Corvette because I like Corvettes. What about a year? This could be an integer, int year. And let's say this is a 2020 Chevrolet Corvette. What about a color? String color equals maybe blue. And what about a price? This could be a double variable such as double price. Let's say that this car is 50,000 US dollars and 0 cents. That's probably enough attributes for this example. Now, what kinds of actions, what kinds of methods would we like our car objects to be able to perform? Let's define two methods, a method for drive and a method for brake. So let's define these. Let's say void drive. And what do we want to do when we call this drive function? Let's have a simple print line statement that says, you drive the car. Let's also create a method called brake. Void brake. System.out.println. You step on the brakes. And that should be good for this example. So these are all of the attributes of the car, the defining characteristics, and these are the methods, what actions our car object can perform. Now let's head back to our main class. This is how to construct an instance of another class. We're going to be constructing a car object. So first we begin with the name of the class, which is car. Next, we can create a unique name for this instance of the class, this unique car object, and I will just call this my car to keep it simple, equals new, and then the name of the class again, followed by a set of parentheses, then a semicolon. So my car now has these attributes. It's a 2020 Chevy Corvette that's blue, and the price is $50,000. And it has two methods, a drive method and a brake method. So let's display some of the characteristics of this car. We can do that within a print line statement. And if we want to display or access one of the attributes of this car, we type in the name of the car, which is my car, dot, and then whatever attribute you want to display. Let's display the model. So when we run this, we'll create a car object, and it's called my car, and we're going to print the model, and in the console window, it's going to display the model. Let's display a few of the other attributes too. So let's repeat the process. We type in the name of the object. The name of this object is called my car. I would like to access the make this time, and the make is an attribute, a variable found within this class. So this is going to print the make and the model, and this is a Chevy or Chevrolet Corvette. Now, what if we want to access or perform one of these methods? It's the same process as before, really. So we type in the name of the object, dot, and then the method we would like to call. So we are looking for the drive method, and that is right here. And let's turn these two lines into a comment. So we're going to call the drive method of my car. And it says, you drive the car in the console window. Now let's apply the brakes. So we type in the name of the car, or the object, dot, and we're going to use the brake method this time. Use step on the brakes. Now with classes, we can reuse a class to instantiate multiple instances of this class, meaning that we can reuse this class to create multiple objects, not just one. So let's reuse this car class to create a second car. Let's pretend that we own two cars now. So let's repeat the steps for creating a car. So we type in the name of the class, car, and we need a unique name for this car object. Let's call this car my car 2, I guess, equals new car. And I think I'm going to rename my car as my car 1. So my car is no longer recognized, so let's just change the name to my car 1. So this will display the make and the model of my car 1.